everyone, I'm Wayne, AWS Solution Architect, and it is my pleasure today to have Keng Pu. Keng Pu is the Executive Director, Quant and Tech Modeling, Treasury Markets of DBS Bank. Together, we shall share on how we empower quants with high-performance compute. Cloud-based services have opened up a new frontier for high-performance computing, otherwise known as HPC. Today, we'll be sharing the benefits of running HPC on AWS. We'll also share how DBS migrated a legacy on-premises grid computing solution to a modern design based on Amazon ECS and AWS Elasticache. DBS also cost-optimized this solution by leveraging Spot instances and Graviton. I shall now let Keng Pu do the sharing.
Hi everyone, it's Keng Pu from DBS Quant team, and I develop pricing engines and trading systems for DBS trading business. In past decades, my team built complex math models for the pricing and risk management of structured products, which requires a lot of computing capacity by nature. And it has always been difficult for me to satisfy customers and traders' pricing needs with our on-prem infra because I cannot scale up and down real time, and increasing any infra will take months. On-prem is also costly to maintain because it requires dedicated IT teams, server rooms, etc., etc. Also, it's difficult for me to access latest hardware or software as the bank controls on-prem very tightly. With all these limitations, we partnered with AWS to create completely new solutions to support DBS growing business needs. Here is a glimpse of the new pricing engine we built on top of AWS. QPE, which stands for Quant Pricing Engine, is built 100% in-house by DBS teams, and it leverages Quant team's extensive model selections, as over the years, my team has already built many math models which can be readily reused. QPE has a microservice-based architecture and provides web APIs, thus achieving full scalability, reliability, and also connectivity. We also fully embrace AWS Cloud to achieve high performance and cost savings, including GPUs, to provide extra speed up. Till today, QPE is already acting as a central pricing engine for DBS trading business, supporting interest rate, equities, FX, and XVA trading business. This slide shows the technology stack of QPE. We use REST API, and we use C++ CUDA to implement pricing models on CPUs and GPUs. We also use .NET Core technology to implement pricing engines and APIs, which turns out to be robust and easy to use. We also use Redis, which is Elasticache of AWS, to implement our data caching, job queue, and messaging services. As Redis is a super fast memory cache, it can provide needed low latency and high throughput. We also use Docker containers with AWS ECS orchestration for scaling and failure recovery, which has been proved to be robust based on our many years' experience. We also heavily rely on AWS CloudWatch for all monitoring and troubleshooting needs. This slide shows one basic queue design of QPE. QPE uses more complex queues, but this one can already give you some idea. On the left is our pricing engine service, which is an API gateway and also as job dispatcher aggregator. Jobs will run in CPU and GPU queues, depending on how complex they are. When one job has been taken by some workers to price, it will be added into a processing queue so that we can retry it in case it failed at worker due to some reason. When job completed, pricing engine will be notified by messaging services to reply back to QPE's consumer. My team has been using AWS for years, and must say our development has benefited a lot from AWS services. AWS enabled us to choose many server types whenever needed, including latest GPU servers to give us needed performance boost. And when we have huge job loads to process, AWS can give us tens of thousands of servers in minutes which is unthinkable with on-prem. AWS also keeps their hardware and software updated, like the latest compiling tools, orchestration tools, memory cache, etc., without any efforts from my side. AWS CloudWatch is very robust and easy to use, which greatly helped our monitoring and troubleshooting. And also, AWS ECS proved to be robust to detect any failed services and restart them quickly so that my users will not be affected. Okay, this chart shows 1 week's scaling chart of a single QP engine, which is designed for risk management purpose. You can see we scaled up to around 5 sovereign CPUs when there are huge loads pending, and scaled down to minimum when everything completed. With the scalability provided by AWS, we can achieve both performance and also cost efficiency. With the help of AWS, my team has delivered many trading systems and pricing engines in past few years. This is not possible without AWS, which enabled my team to focus on Quant application design and implementation, and to spend minimal efforts on infra itself. As of today, QP can reply customer RFQ pricing requests with minimal latency, and is processing hundreds of millions of revaluations every day. All these improved customer journey and led to happy traders and happy risk controllers. Thank you all. Here we will pass back to Win.
Thank you, Geng-Pu. Indeed, today many HPC customers have been constrained by the need to purchase and deploy on-premises infrastructure in order to gain access to the best technologies for their applications. Rather than focusing on the business and research value they provide, they build and manage data centers and spend precious resources on modeling on how to avoid over or under provisioning to meet evolving demands of users. HPC users are looking to innovate around their research, development, and production workloads without the constraints and bounds of traditional on-premises solutions. AWS offers customers the ability to dynamically scale infrastructure, which means HPC users no longer experience the long wait times and lost productivity associated with limited on-premises HPC infrastructure. With access to the latest technologies, customers can maximize performance to get to market faster and increase operational efficiencies. DBS also cost-optimized these solutions by leveraging Amazon EC2 spot instances, capacity-optimized allocation strategy which will automatically provision EC2 spot instances from the most available spot instance pools and minimize the possibility of a spot interruption. They ran Elastic Cache using our Graviton2 R6G instances. These are custom built by AWS using 64-bit ARM Neoverse cores that deliver 45% price performance improvement. With access to cloud-based services like data analytics, machine learning, ultra-fast storage, and low-latency networking, no matter the workload, it can run efficiently on AWS. Customers can configure and manage their HPC environment with AWS Parallel Cluster, access via GPPS networking with Elastic Fabric Adapter, and choose from nearly 500 different Amazon EC2 instances, from reservoir simulations and computational fluid dynamics to drug discovery. Customers can use the virtually unlimited capacity and flexibility of AWS to run their HPC workloads. To gain more confidence and hands-on experience with AWS, access the digital training built by AWS experts, attend our instructor-led classes by qualified AWS instructors, and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. Validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take the time to fill out our survey form and let us know what you think.